Okay, so we're back with the second video here. First attempt with this one, so the calculus seems to be working well so far. So we're going to take a look at question 4. It's asking for two things. First, it wants to know the correlation coefficient, and then it wants to know if there is a linear relationship that exists. Okay, so we'll walk through the two pieces of this here. So there's a couple ways to do this, but as much as you can do this with technology, I will utilize that. So what we're going to do it here is I type the data in to the calculator already, so I don't have to like redo that for you every time. So I did that, so I'll just kind of review this with you. So there's the data typed in. Make sure your data values are all accurate, because if you have inaccurate data, you're going to find it difficult to obtain the correct answers that you need to obtain here. Once you type the information into list 1 and list 2, we're going to go to stat. This time, so I am a little cautious. Yeah, no, actually, this time we're going to go to test, because in the test one, unlike the calc one where you found the correlation coefficient here, they're asking a different question about if this is a linear relation or not a linear relation. And the test one will determine both of those for you. So we're going to arrow over to test. We're going to go up here to choice. On my calculator it's E, and maybe something different on yours, where it says linear regression t-test, and I'll press enter. You shouldn't have to change anything here, but there are certain things you want to make sure are in place. You want to make sure your information is in list 1 and list 2, like it has been for me. You want to make sure to just leave the frequency as 1, and you want to make sure that this portion here where we have row, that it's set to be not equal to 0. And I won't go into the specifics at that time. It's really not necessary for the calculation here. As long as you have all those in place, we can go ahead and press calculate. And there's two bits of information that you want to get from here. You're going to see y. You're going to see the equation written in a bit of a different form than you do for the one under calculate. Let's go down here and find the r value. And if we arrow down, we'll find that the r value is equal to 0.632, which seems to correspond with choices A and D. So it looks like we could cross choices C and B, cross those off automatically. But the second thing they're asking is if there is a linear relationship. If you wanted to determine a linear relationship with technology, okay, this may differ from what's in the book, but the question you can ask yourself is P less than alpha. And in this case, you're probably familiar with some of the work with alpha around hypothesis testing. So the normal expectation for alpha to use in this case is where alpha, let me bring this down a little bit here, where alpha is equal to 0.05. So we want to find 0.05, or find the p-value to make that comparison. And we get that p-value right here, which is rounded to the nearest 3 decimal places, is going to be 0.068. And because 0.068 is not less than 0.05, we will conclude that there is not a linear relation in this one here. So if p were less than alpha, then we would say there is a linear relation. So since this is false, we can say that there's no linear relation. Okay, and that's going to be question 4. Let's take a look at question 5 now. It says a variable that is related to either the response variable or the predictive variable or both, but which is excluded from the analysis is a lurking variable. And if you want to kind of understand exactly what this means, I recommend a page 188 in your textbook. And I think the example they talk about there is the example that when the electric bill goes up, crime goes up. And the idea is it's not the electric bill that drives the crime. It's that usually the electric bill will increase because of a lot of heat, and so it's not the electric bill that makes crime go up. But apparently, like a lurking variable would be that the heat outside is causing the electric bill to increase. The heat outside may also be driving an increase in crime. So that would be what would constitute a lurking variable. But you can look at page 188 for yourself on that question. Okay, so let's go ahead and we'll take a look now at question 6. And what is the question asking here? It wants the equation of the line of best fit. It wants to know if these choices are reasonable or if they are not reasonable for question 6. So in order to find the equation, we can take a look at the data here we have. We're going to go ahead and plot this into the equation again. So we're going to go back to our lists, and we're going to enter it here. Oops. And you forgive me, I'm doing this over my lunch where I work, and it's a little noisy outside. As soon as I play loud music, which is a little distracting, you hopefully don't hear it too much here. So I'm going to type in the commute time in minutes in column 1 and then the number of absences in column 2. Oh, this looks like it's the same information. No, it's the information is like the same description, but different data. So 72, 85, 91, 90, 88, 98, 75, 100, 80. Okay. And then go to column 2. This would be 3, 7, 10, 10, 8, oops, 15, 4, 15, 5. Okay, so at least the data matches. I'll just kind of take a quick look at everything, make sure that everything looks good. And sometimes it's easy to make a quick mistake here, but I think I'm in good shape. Okay, so I want to find the graph of this line, and notice that the equation of this is written in the form of y hat is equal to, and you'll notice that in the book, this is written in the form of, was it beta 1x plus beta, and that's going to be 0. On the graphing calculator, it's just going to be written in the form of y equals ax plus b. This method is shown in the calc portion of your calculator. Under test, it's written differently. Be careful of this. All right, so what we're going to do to utilize this form, since this is consistent with the calculator and this particular function, I'll show you what I mean in a moment. We're going to go to calculate, see how the linear regression ax plus b. So this is the one that's going to be best to use here so you don't confuse your slope and y-intercept. So we're going to go to 4, and we're going to go to second y1, comma, second y2, and this is going to help us to calculate the equation of the line of best fit. So for y equals ax plus b, the a value is 0.4485, and the b value is negative 30.27 or 2677. The book specifies that when doing this, it wants these values for the slope and y-intercept rounded to 4 decimal places. But in this particular question, it's only asking it to be rounded to 2 decimal places. So to put this equation together, I'll put this over to the right side. So we'll say y is equal to, and that's going to be 0.45x, and it's going to be minus 30.27. And that seems to match the choices we have. Well, let's see. It matches the choices we have for all of these. Okay. Well, then I guess that's no mystery to which equation is correct. But then it asks the following question. What would be the predicted number of absences if the commute time was 95 minutes? So to make a prediction, what we're going to do for that second part is we'll let x equal 95, and we're going to put it into our equation for the line of best fit. So I'll do that over here. So it's going to be y, and by the way, I put that as y hat, equals 0.45 times 95 minus 30.27. And I'm going to go ahead and put that into the calculator here. I'm going to do this in one foul swoop. So 0.45 times 95 minus 30.27. The answer it gives me for this then, for my predicted value, is going to be 12.48. But it says to round that to the nearest whole number. So it says to, let's see, round the predicted value of abscess to the nearest whole number. So when I round that, I'm going to round that to 12. So you want to be careful about this. So it says we're predicting in this case 12 absences. I think what happens here is some people put it in for y and they get that for x then, but this is the x they're giving you. They're actually to make a prediction about y. And the question is it reasonable? And so what you want to do for a case like this, when you don't have an exact value of 95 here, we'll take a look at some values just below and just above 95. So just taking a look, for example, for 90 and 91, we have 10, which is just below 95. If you go a little above 95, we're at 98. That seems to be 15. So if it's, in other words, if we have less of a distance, we have fewer absences. If we have more of a distance, we have more absences. Seems to be pretty consistent. So we can say for question 7 that the answer to that is going to be choice C. That, or not 6, sorry, for 6, that for question 6, that this is a reasonable guess. Because remember, when you're making a prediction, this isn't going to be an exact amount. It's just giving you a good estimation based on the regression in the line of best fit that you calculated. Let's go ahead and take a look at question 7 now, because the answer to that, I'll just say that there, is not going to be choice C. If you want some directions for how we do this kind of question, I'm going to recommend, oh, and by the way, for question 6, I'm going to recommend you want to look at page 203. And for question 7, I'm going to recommend you look at pages 202 and 203, and these will all be in your textbook. You want to look at those? Okay, so it gives you a lot of information. The one thing you want to focus on is it's giving you the equation of the form where it gives you the y-intercept first and then the slope times x. So one thing you want to be able to pick out of this is the slope. So make sure we're on pages 200, 203 for the wording of how you write these interpretations. And the choice for this is going to be for a 1-point increase. So this is where the value of x is equal to 1. In administrating rating, we estimate the administrator's raise an increase of $2,000. Okay, so that's going to be choice D. And again, if you want to look up the proper interpretations of that, please look in your textbook on pages 202 and 203. I'm going to start a new video in just a moment.